record this, shrink that. Where do we want to begin here?
Further down.
Okay.
Yeah, number 1 would be perfect.
Okay. Limits. Have we done limits, you and I?
Partially.
Partially? Okay. Well, the easiest way to do limits is just to substitute. They'll be very easy as long as we end up with something other than 0 over 0. The first one, substitute 5 for x, and what do you get?
25 plus 20 plus 13 over 2.
And that's the limit. That's 58 over 2, or 29.
Okay.
Number 2. Now we're getting a little bit harder, because when you substitute on number 2, what do you get?
0 on the bottom.
And 0 on the top. 0 on the bottom wouldn't be enough to make it a hard problem. If we had a number on top and 0 on the bottom, then we know the answer is infinity. In other words, 2 divided by 0 is infinity. They may choose to call it undefined, but it's the same thing as far as I'm concerned. I prefer infinity. But this, when I substitute 0, I got 4 minus 4 over 4, or over 0. So this is the indeterminate 0 over 0, which means we have to do a lot more to it before we can figure it out. Now, this is not a typical, I would say this is a more of a second degree one. Usually they start you out with something a little easier. Let's see if I can spot it. Let's look at 14. Before we do this, let's look at 14. I prefer to do my calculus in short bursts. Factor the numerator in 14.
14.
Uh-huh.
So that'd be 25 minus 15 minus 10 over 0.
X minus 5 times x plus 2 over x minus 5. And notice that when x goes to 5, I got 0 over 0, right?
Cross it out.
Right. And once you do that, in other words, once I cross out that factor with that, now I can substitute and I get a number. So what's this limit equal to?
Negative 2.
Not negative.
2.
Uh-huh. In other words, when I substitute 0 for x, I just am left with 2.
Oh, okay. I see.
In other words, the function is now x plus 2. What's the limit of x plus 2 as x goes to 0? It's 2. Okay? So this would be what I would call an elementary, a first level difficult limit problem. It's difficult only because it's 0 over 0, which means you always have to do more. Okay? Well, in this problem up here, I can't do anything like I just did. I can't factor that. But I can do, I consider this more of a second or a third degree of difficulty. What I'm going to do is I'm going to multiply the top and the bottom by the conjugate of this. Just another technique. Notice what I've done. I'm multiplying that fraction by the number 1. That's all. It's just my number 1 is very specific to this numerator. Now, when I do the multiplication in the numerator, notice that when you have the conjugate, you're basically looking at the difference of squares factored. So, in other words, if I told you I had a minus b times a plus b, it wouldn't matter what a and b were. A could be the square root of 16 plus x as far as you care. What you know is that when you multiply those two back together again, you're going to get a squared minus b squared. So multiplying these two numerators is relatively easy. What's the answer going to be?
So it would be 4 plus x plus 4.
Yeah, in other words, it's going to be the square root. Well, I'm going to lose the square root sign because when I multiply that term by that term, it just ends up being 16 plus x. And then it's minus 16. Well, the 16 minus 16 leaves just x.
Oh.
So this thing has now turned in to x in the numerator, and in the denominator, never multiply these out. Always leave them factored, because you'll see why. That's my denominator now. Now I can cancel the x's, leaving a 1 behind, so that now I have this. And now that's what I have here is the same as what I started with. That is the same as this function. But I've altered it in a way that now when I substitute, what problem is this? Somehow I scaled down without meaning to. Now when I substitute 0 for x, what do I get?
4 plus 4, which is 1 over 8.
Right, 1/8. So what started as 0 over 0, which is called indeterminate because it can be most anything. It can be 0, it can be infinity, or it can be a number. You don't know until you've messed with it. There's basically 3 techniques in limits. One is factor. Number 8 is a factoring problem. Let's do number 8 real quick.
Okay.
I'm assuming number 8 gives you 0 over 0. Certainly gives you 0 in the denominator. 4 minus 2 is 0 in the numerator also. So if we want the limit of this as x goes to 2, I've got to do something with it. Well, how's the top factor?
It would be x minus 2. Or no, plus, wait. It would be minus 2. Plus 1.
There's 2 reasons you know it has to be minus 2. First of all, if it was plus 2, this problem wouldn't be doable.
Yeah, it wouldn't be a negative.
What's that?
Yeah, the x wouldn't be a negative.
No, you wouldn't be able to cancel them out. The only reason that factoring the numerator works is because now I can do this and this.
Oh, so you know that automatically that it has to have an x minus 2 in there.
Right. That's what I'm saying, is when you're factoring this, know that one of your factors is this denominator.
Okay.
So you should never make that mistake making it x plus 2 times x minus 1,
True.
which is not correct anyway, but in other words, so you don't want to make that mistake when you're factoring that quadratic, but even if you do make it, you'll see that you've made a mistake, because the secret on all of these problems is you end up with a factor that cancels. Now what's the limit as x goes to 2?
2 plus 1 is 3.
Okay. Let's see. Number 2 was harder difficulty because it's much harder to think of multiplying that thing by the conjugate than it is by factoring and canceling out factors. But number 3 is similar as number 2. They're putting the tougher ones in the top. Notice that the limit as x goes to 16 is going to be 0 over 0. No, it isn't. Ah, I got the wrong sign on this thing. Minus 4. No, I was right in the first place. What's this limit? You don't need to do anything to it. Do direct substitution. What do you get?
Direct substitution.
Uh-huh.
4 over 0.
What is it over 0?
8 over 0.
What's that limit equal to?
16.
Any number divided by 0 is infinity. Unless it's a negative number divided by 0, and then it's negative infinity.
Okay.
That's always infinity, and notice why. If I take 8, and I divide it by 1, I get 8. Now let's start reducing the denominator. I'm going to reduce it to 1/10. Now I get 80. Now I'm going to reduce it to 1/100th, and I get 800. Notice is that as this denominator goes closer and closer to 0, the quotient gets bigger and bigger. So when I do actually have 0 in the denominator, it's infinity. So this isn't a hard problem at all. This does not require anything else. The only hard limit problems are when it comes out 0 over 0 when you first substitute.
Okay.
Okay? So number 4. As x goes to infinity, that we're talking end behavior. When you're talking end behavior, only one of these 3 terms makes any difference. Which one is it?
The largest one, so it would be 6.
The highest degree one. Yeah, not the size of these coefficients. It's that right there. So this is the only thing that affects end behavior. We can basically cross these 2 off, not consider them. Well, what happens to 5x to the 6th as x goes to infinity?
The left and right both go up, rise. So it's infinity.
It's infinity is the answer, yes. And this is only asking about the right-hand end behavior. In other words, it didn't say as x goes to negative infinity also. It's only wanting the limit as x goes to positive infinity. But that is right-hand end behavior, and right-hand end behavior is always only a function of the largest degree polynomial. Look at number 5. X to the 4th minus x to the 3rd all over x squared as x goes to minus 6.
So negative 6 to the 4th and 6 to the 3rd.
Let's simplify this thing before we plug it. It's not 0 over 0. We know that.
Yeah. You can subtract the other degrees on the top.
So what does this thing simplify to? What is
X
that?
over x squared.
Huh?
X over x squared.
No. Break it into 2 fractions. Turn it into that fraction minus that fraction. What's x to the 4th over x squared equal to?
2.
Subtract the exponents. What's x to the 3rd minus x squared over x squared equal to?
X to the 3rd over x squared.
Uh-huh. In other words, the right side of that fraction. Notice how I'm breaking that up into 2 fractions. The first fraction is x to the 4th over x squared, which is x squared. Second fraction is x to the 3rd over x squared, which is what?
X.
Mm-hmm. Now, substitute negative 6, and we'll have an answer. And much easier than it would have been if we'd have substituted it in here. That's a lot of math. I might have had to pull out the calculator. But this, I do not.
So it'll be 42.
Uh-huh. We'd have gotten 42 if we would have substituted it into the whole thing also. But it's generally easier to simplify when you can. Okay. Immediately I see that this isn't really easy. This isn't even level 1 degree of difficulty. What's the answer?
It'll be 1 plus 2 minus 11 over 4. So that'll be 3 minus 11 negative 8 over 4, so it'll be negative 2.
Yeah. Those are really easy. End behavior. Number 7 is another end behavior problem. Well, when I'm going to negative infinity, I'm still considering only the largest degree. There's the top. Is that a 3 and a 5? Yeah.
Yeah, it's 2x cubed plus 3x cubed.
Okay. Now, as I'm considering as x goes to negative infinity, what's the top do?
That's like the bottom. It's bottom heavy, which makes it a 0, correct?
Correct. In other words, if the bottom blows up greater than the top, and it does because it's 1 higher degree, then you're basically going to end up with 1 over infinity, and that is 0. Anything over infinity. 10 over infinity is 0 also. Number 8, we did that. Number 9 is a direct substitution. Is that x going to 1?
So how many times?
What's number 9, the answer?
3x squared plus 4x minus 5x. So it'd be infinity, I believe.
No, as x is going to 1.
Oh, so I just substitute.
Just straight substitute.
So it would be 3 plus 4 minus 5. So that would be 2.
Okay. And number 10.
I could not substitute.
Well, you could, but you're going to get 0 over 0.
Yeah, I'd rather factor.
So what do we do here?
X minus 3 plus 1. Or x minus 3 and x plus 1. It would be 4.
Good. Limit problems are actually kind of fun. In other words, we've really only seen 2 techniques that we've used today. One is where you factor and cancel, and the other is where you use the conjugate. You multiply by the conjugate over the conjugate to manipulate that function.
True.
And this is one of those. Must be a negative in front of that, is there?
I don't think.
If there isn't, then it's not 0 over 0.
Yeah, I think she might have made a mistake. I think she meant to put a minus 5 on top.
Well, minus x works also. Minus the square root of x also gives you 0. In other words, when we substitute 25, now we get minus 5 plus 5, 0 in the top, 0 in the bottom. Let's assume this was the problem, because this is actually a little more difficult. If it was just square root of x minus 5, I think maybe that'd be a little easier. So this is not one that we can factor.
Do we have to multiply it by x minus 5?
Well, let's change that numerator so that it reads like this. Same thing, right? So the secret is to what? Since I can't factor the numerator, what am I going to do? In other words, that's technique number 1. There's a second technique that we've used. Multiply top and bottom by what?
By the numerator?
No, by the conjugate of the numerator. Or the denominator, whichever it be. In other words, I can't factor that, right? In other words, I cannot factor and cancel. But I can multiply the top by 5 plus root x. That's going to be very helpful. But if I multiply the top by that, I got to multiply the bottom by that also. Okay? Now, what do I get in the top when I multiply those two things? Again, that's difference of perfect squares factored. So what would the unfactored form be? You can get pretty good at multiplying these two together very rapidly.
Okay.
What is it?
It'll be...
Square 5.
Yeah.
It's the difference of perfect squares. Now square the square root of x.
So, plus or minus x?
Not plus or minus. That's what the top is. When you multiply 5 minus root x times 5 plus root x. The bottom always leave unmultiplied together.
Okay.
Like that. Okay? Now notice...
They can cancel.
Well, they can, but not exactly, because 25 minus x is not exactly the same as x minus 25. What is that equal to? In other words, normally they're exactly the same and I just cross them off. What do I have to do to cross them off here?
Multiply...
-1. What I have circled there is -1. If I say a minus b divided by b minus a, that's always -1. And that's what we have here, is we have an a minus b all divided by a b minus a. Okay, so I can cancel them, but I got to leave a -1 behind. Now, I'm in good shape though, because I don't get 0 over 0. What is my answer now?
That is 5 plus 5 is like 110.
Okay. Now, if that was x, square root of x minus 5, I'd have done exactly the same thing. In other words, if this really was the problem, you thought she made a typo, well, I'm still going to multiply by what? Top and bottom.
Yeah.
By what?
By x plus 5.
Square root of x plus 5. In other words, it's got to be this same thing, only with the opposite sign in the middle.
Correct.
What's that times that equal to? Quickly.
X minus 25.
Yeah. And now, that's going to cancel with the one I have down here. So that cancels with that, leaving a +1. And I still have the square root of x plus 5. So this one actually goes to positive 1/10 instead of negative 1/10.
True.
Okay. Well, let me see if I can find one. What's 12 going to be?
12.
You got x
Plus-
going to negative infinity, so we're talking about end behavior.
Correct. So it would be 7 is the highest.
Okay. So what is, in other words, the only thing we have to answer is what is the limit of this as x goes to negative infinity?
Would it be infinity?
Positive.
Negative.
Yeah, excuse me, I meant to put a negative sign in there. Yeah,
Or
because
negative.
when you take negative infinity to an odd power, it stays at negative infinity. But then when you multiply negative infinity by a negative 3, it becomes positive infinity. So that whole thing is positive infinity. And you do need to distinguish between plus or minus. So this is one where you would definitely give your answer as infinity or positive infinity, not ever undefined. Number 13. What's the limit of that?
13. So it's top heavy. So it'd be infinity.
Correct. It's not just if it's top heavy. If this was the problem, that's not infinity. That's going to be negative infinity.
Because there's a negative in front.
Well, yeah, because of that negative 5. In other words, this becomes minus 5x squared, and then when you put it infinity for x, it stays infinity, but a minus makes it negative infinity. So you do have to distinguish between negative and positive infinity on your answers.
Okay.
Let me just see if I can see one other 2-minute problem here. Number 15 is a good one. So 15 is the same as what's the limit of that as x goes to negative infinity?
That would be negative infinity.
Well, these cancel, and what you're left with is the ratio of their coefficients.
So
In other
negative
words,
5
if the top and the bottom is the same degree, then the end behavior is the ratio of those coefficients.
Oh. That's news to me.
So 16, the last one we'll do. What's that?
Okay.
What's that going to be?
Is that a 7 on the top right? Yeah, I think that's 7.
Yeah, they're both. The top is 7 and the bottom is 7.
So would it be 4 over negative 9?
Yeah, negative 4/5. Exactly.
Okay. Thank you.
You're welcome. Talk to you later, Taylor.
Have a good night.